Okay, y'all, we're on Module 9A, Lab 18. Do you have your books open to that page? And I've been mentioning to you all year that we would cover some of the creatures we've talked about when we look at the zone in which they live. So we're starting there now, into the zone. So we're going to start with the intertidal zone. And we're going to spend a lot of time here because, as you know, the intertidal zone, there's a lot of life there, okay? So did y'all have to define that today? What is the intertidal zone? It's also known as a littoral. Littoral. Say it, littoral. Say again? L-A-T-T-O-R-I-A-L. So I think instead of saying literal, because it sounds like literally, we'll call it littoral. Okay, so let's see what it is. All right. And one more time. There we go. All right. So the intertidal zone is the area of shoreline between low and high tide. All right, so sometimes it's underwater, sometimes it's not underwater. It's also called littoral, L-I-T-T-O-R-A-L. And you can see that there are going to be some environmental variations that take place, obviously. At some point they're under the water, at some point they're not under the water. So you can imagine that would lead to stress. So stressful situations for these creatures. We've looked at some of them already. We dissected a clam, right? That's one of these guys here. What else did we dissect? Today we were supposed to dissect a sea anemone. But remember I told you those were back ordered? They are still back ordered. Don't know what the deal is on the sea anemones. I don't think there was a big run on them. Like, oh, everybody wants sea anemones. They're not a very exciting dissection, honestly. So I'm not sure what the deal is on those. So I went and got something else at the grocery store. It's right over there. All right, which we will do today. That's the thing I left at home and I had to go drive home to get it. Okay, intertidal communities, they're stressed out, all right, because they've got things to deal with. Think about it. They got salt, then they have no salt. They have sunlight and temperature, and then they're cold under the water. You see all these different things. Inundation versus drying out. So the sea, land, and air play important roles in the abiotic conditions. We all remember what abiotic is. That was on your quiz, yeah? The non-living things, right? So those would be water, salt, temperature, sunshine, seasonal changes. Storms, yeah. The organisms in the intertidal zone are subject to many abiotic stresses during low tide. And look at here, crashing waves when it comes in. Y'all have been in the crashing waves, right? I've told you all my story about Hawaii, when the wave nearly killed me. Oh my gosh. It was terrible. Turned me in a, did that ever happen to you, Elijah? Boom, like I was rolling like this. And they say in Hawaii, you get off the plane practically, you know. They used to put the layover. Now they say, never turn your back on a wave. And I learned why. Because you can't, I'm running, like, you know, and it called, boom, yeah.
We went to a beach, I think it's called Johnson Beach in California, and my brother and my cousin were chasing the waves, and one of the guys who, I guess, works at the beach, there was no one there except for us, but someone who either frequents the beach or worked there came and was like, I wouldn't let them play too far out, because it's like, there's the beach, and then like a 30-foot drop, and he said it's like a washing machine. Basically, it just kind of continually does this. And
if you've got nothing to put your foot, if you don't, because like I could at least put my feet down, you know, I mean, I was trying to put my feet down, but I could feel, I was hitting the ground, you know, boom, 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 like a washing machine, but slamming me into the ground. So at least I had that. Yeah, so that's one of the clues, though, when nobody else is at the beach. That's what happened in this Hawaiian beach. Everybody was over here, and there was this one part, said, look, nobody's over there, let's go. Well, that's why there was nobody over there, okay, because it was very dangerous, very stressful. So be careful. All right, they suffer stress at high tide due to biotic pressures. Guess what comes in with high tide? Predators come in and say, it's dinner time. Next, organisms seek refuge in the substrate. Okay, that's a word we need to know, a substrate. That is, what is it set in? Like, for instance, the substrate of a coral reef is the coral that the corals built, right? The calcium carbonate coral they built. On the beach, what is the substrate? Sand. You've all seen that you see something digging under the sand, right? Right away you see like a little hole, and if you dig down, you'll find a little critter down there. That's because they're burying themselves in the substrate. In that case, it is the sand. In other places it would be mud. Okay, other places it might be really rocky, or like I said, like the coral. Some IT, so IT stands for intertidal. It's too long to write it down every time, so I'm going to call it the IT zone, the intertidal zone. Some of them, in fact, the vast majority of beaches on this planet are rocky beaches. Who knew? In Texas, we think they're all sandy beaches, because that's what we have in Texas, is a sandy beach. In fact, all the beaches on the Gulf of Mexico are sandy beaches. But think about like the West Coast. If anybody's been up to like Seattle and places like that, they're all rocky coasts. Might find a little tiny spot of beach. I mean, honestly, Hawaii's that way. They're very rocky, and then there's this little tiny cove that has a beach in it. I was really surprised that the beaches were so small in Hawaii. There are lots of them, but you could see from one end to the Texas. You go down and you can't even see the other end of the beach, right? It just keeps going. Yeah. So, all right. So the rocks can be a substrate as well. Others have sand, others have mud. All right, so our rocky intertidal zone, here we're looking at it. Now you can imagine with the waves hitting these rocks, they're going to cause some erosion of the rocks and cause there to be maybe a rocky sand, if you will, like more gravelly, like. So let's look at the rocky intertidal. These communities live in steep, harsh, rocky crags with little or no sand, maybe gravel. Some animals can burrow into the rock, but most creatures hold on tightly to the substrate. They hold on to the rock. Do y'all remember we talked about limpets? They only had the one shell, right? But they would like suck themselves to the side of something. They will hold on to the rocks. We also were going to look at trying to dissect barnacles, and I could not get any barnacles either. So I'll show you some pictures of them. Organisms that hold on tightly but can still move around, and these are benthic, are called epifauna. Okay, these words get a little bit tricky here. So they can move around, so they might hold on to something for a while, then move around. Epifauna. If the epifauna attach themselves permanently, they're considered sessile or sessile. Remember, that means attached. We've talked about that word before. We know that sponges, for instance, are sessile. They attach to something and stay. So they might find a spot that's so advantageous that they just decide to move in permanently. There's a constant struggle to avoid desiccation. Another word, desiccation, you might already know the word, right? It means to dry out. Those little things you find in your packages of food and stuff, those little packages that say do not eat these, they're called desiccants. They're keeping your food from getting humid in there. They're taking the humidity themselves, keeping it dry inside there. If you have any vitamin capsules, like they always have those in there. And then some foods. This area is further broken down into zones. We call that vertical zonation. It refers to the horizontal bands of organisms living in the area, and we're going to cover those here in a minute. So some may live deeper, some may live higher. Think about those little crabs that crawl along on the beach, right? The land crabs. They're going to be included in this group right here. They can swim, but they prefer to crawl. Good? Okay. So here we go. The zones right here. So we can see the low intertidal, the mid intertidal, the high intertidal. So at high tide it would reach up this high. And here it is down at low tide all the way down here. Subtidal are these guys down here. All right, so the shoreline abiotic conditions, exposure to sunlight, drastic temperature changes, drying out due to water evaporation at low tide, increased and then decreased salinity, the amount of salt, So are y'all on the one here saying abiotic conditions in the rocky intertidal zone? Is that your blank?
Yeah.
So all that writing y'all been doing has been in this little tiny area here? Oh wow, it's not a lot of writing space there for y'all. So here it says a fight to stay hydrated. Predation, of course. When the tide is low, are there going to be predators there? What about birds? They're predators. They're going to come in at low tide. At high tide, we'll have fish and other swimming creatures coming up. Wave action. The waves are violent, like we discussed. Boom, you know, that'll hit on them, and they have to be able to have some strategy to survive the violence of the waves. Increased waste and lack of oxygen. So think about that. Most of these creatures are breathing, getting their oxygen from the water, and if the water is not there, can't really get any, they have to hold their breath all during low tide, yeah? They have to save some. Notice this little cool deal right here. That little thing's called a tide pool. Y'all have probably seen some tide pools where the water stays there during the low tide. The problem is, though, it's not moving around, and it gets hot from the temperature, you know, from the sun shining on it, that kind of thing. So we'll see that it's its own little habitat area, its own little special place. We'll see the creatures that live in tide pools. All right, the rocky intertidal, still the abiotic conditions of the rocky intertidal zone. A fight to stay hydrated, here we are. So I just had here wind, salt, crashing waves. It's a violent place. I think that's just repeating. A lot of time these coastal regions are beautiful. These are the places where a wave will hit and a giant splash will come up and people take these awesome photographs and stuff like that. Also, you can find things like this. This is some, what do you call that, driftwood? You ever seen driftwood? It's been, you know, sanded, if you will, by the waves and the action there, and it ends up, somebody put these obviously in an artistic arrangement there. All right, so what about the organisms that are living there? In our low tide zone, we dissected a starfish, yeah? Mm-hmm. Okay, so they're down on the low tide, so they stay underwater the whole time, but it does get more shallow at that spot and probably warmer and less salty. We have sea anemone, that we're supposed to look at those guys today. Then we have our middle tide zone. Some of our sea stars can bury themselves right there. Barnacles, we'll look more closely at those in a minute. Mussels, a type of clam, yeah. Limpets, those are the ones that hold on tightly. More barnacles. Here we go in our high tide zone area. There's our tide pool. I don't know what a sculpin is. Little fish? Periwinkle, snail, right here, some snails. Isopods are everywhere. Those are just basically beach bugs. And then our crabs, hermit crabs, regular crab, sand crab, rocky crab, that kind of thing. So strategies for staying hydrated in the IZ, hiding in rocks and tide pools. So the urchins will do that. In fact, urchins are some of the ones that find a nice little spot in a hole in a rock. And they will sit there and then stay there. They will actually plant themselves there. Typically, they will continue to move around when the tide comes in, however, so they can feed. And then others will seal in the moisture, like those limpets will clamp onto a rock and seal in that moisture. Chitons will do the same thing. They're a similar type of shell creature that has one side open.
Did you want examples, or is this just for our benefit?
Is there a spot? If you're running out of space, then you don't have to necessarily put that on there. Here are some limpets. Look at them holding on. And they will have trapped some of that water inside their shell area that would give them enough, presumably, enough oxygen. So tide pools can be a whole lot of fun. Here's a guy walking around over here on the right looking at the life in the tide pools. They're not as common at the Texas beaches because we're in a sandy place, right? But you can find some areas that are sort of tide pool-like, especially on the jetties and stuff like that. So the plan is, if we go on our trip, when we go on our trip, is to go to the jetty and the sandy beach, right? Yeah, so maybe every week I should remind y'all about safety at the beach. One of the things you can't do is go off alone. I had that happen last time. So somebody goes off alone, and then I'm like, where is so-and-so? They could be carried away to Mexico. I mean, you know. So you got to have a buddy system all the time. All right, intertidal feeding and reproduction. Sessile organisms don't move, so they produce planktonic gametes that will be broadcast. So their gametes will go out into the waves when the high tide comes in the water column at high tide, right? They timed reproduction for high tide and spring tides, which are the bigger ones. Can y'all see what these things are? There's a starfish. These are all sea anemone. And notice at low tide, when there's no water, they'll actually can close themselves completely up, put all their tentacles inside of them. So you can see all the tentacles are folded up inside of these guys over here. These guys to the right have a little more tentacle action still visible because there's a tide pool right there. So they might could still feed at that point. So how does it work for sessile organisms? Sessile organisms, they wait for the tide to come in, essentially. Okay, I think next we're going to look at wave action, right? Yeah, so wave shock. Shock to animals from the waves, they are very violent. Here we can see a giant green sea anemone. It lives in the low intertidal zone. In sheltered location, they can grow very tall, but when they're not, they kind of stay stubby like that, kind of short. And it has to do with the amount of violent wave action coming in during the changeover from low to high tide. So they'll reduce the drag that way. They can also actually squinch themselves down, you know, they can make themselves shorter. And like I said, they can close up and get those tentacles all closed in there. So a sea anemone is basically a bag, a little sack with the tentacles on the top. Remember they're in the phylum Cnidaria. They have those little nematocysts on the end of their little tentacles right there. That's how they catch their prey. So when we cut them open, that's all we really see. It's just a little bag of muscle. Looks like they have some symbiotic action going on here with some of these shell creatures. Let's see. I think that's all I have for wave shock. It's just the, trying to avoid the violence of it. And some of them dig down, right? Some of them will dig down in the substrate, whether it be sand or in some cases crags in the rocks, that kind of thing. All right, so a pattern of organization. So this is the next one right here that talks about vertical zonation. Okay, the upper intertidal zone is stressed by physical forces that discourages life there. Moving downward toward the water to the middle and lower IZ zones, physical forces diminish and competition and predation rise. Okay, so they each has their own set of stresses, and we will see where there's more water, there's more life, essentially. Elsa.
Yeah. We have places for the upper, middle, and lower. Is this what we're writing in this places?
Let's see.
Or do you have a different?
I think I might have a different.
Okay.
We'll come back to it if we need it. Okay. Waves move in at in a vertical circle. Okay, so they're going to come in whoosh, whoosh like this. Remember, the wave is just energy that's really just going up and down. And then when it hits the bottom, it causes that to break. That wave breaks that way. And so we're going to see here some of these creatures, how they're going to have greater, like the splash zone is going to be the most violent right up here is when it's going to stop that. Notice we have a tide pool up here. We have some birds looking for some snacks. All right, so let's see. I'm trying to see. The environment determines what organisms live there. The higher up the creature lives, the more time it must spend exposed to air. So this is going to be our upper. We have that one? Upper intertidal characteristics. I think that's this part right here. The biggest enemy of these organisms is drying out, desiccation. Some will find a place to hide until the tide returns, bringing in salt, water, oxygen, food. And one of the best hiding places, like I mentioned before, is going to be a tide pool. All right, so this is the upper intertidal zone.
What did you want us to write for this?
That their biggest enemy is desiccation.
Okay.
So drying out, and also lack of oxygen because there's lack of water, right? They don't have any oxygen available to them. So we're gonna see a picture here of a tide pool. There it is. And I think we'll have a video on this. It's beautiful. So once again, Hawaii has a bunch of these. Some famous ones, in fact. Did you go to the olivine pools? Olivine pools, I think, yeah, they're beautiful. And then the Nakalele blowhole, Nakalele. Let's watch a little video back. It's fun stuff.
For an animal to survive in a marine environment, it's always a challenge. But what part of the marine world presents the most challenging conditions? One of the areas that surely has to top anybody's list is the intertidal. The intertidal is the area between the lowest low tide and the highest high tide. The conditions here are some of the harshest of all marine environments. The organisms that live in the intertidal are subjected to wild fluctuations in salinity, temperature, and of course they're constantly punished by relentless wave energy. The challenges that the plants and animals here face are unlike those of any other part of the marine world. When the tide goes out, we're able to access the intertidal from the shore. This area that's underwater during a high tide becomes exposed, and what's left behind are tide pools. Here in Hawaii, the tide change is only about 3 feet on a really big day. That means that tide pools here are just a few feet and sometimes only a few inches deep. Nevertheless, they remain fascinating places to explore. As soon as the tide goes low enough that a tide pool is cut off from the ocean, the sun begins to heat the water and it starts to evaporate. As it evaporates, the salinity or saltiness of the water increases. This is really stressful to most organisms, and the plants and animals that live here have to have adaptations that allow them to tolerate extremely salty and hot conditions. The first thing you notice in these tide pools is that it's not a coral reef. Corals can't handle these types of conditions very well, and the substrate or the bottom of the tide pool is generally either bare rock or is covered with algae. Amazingly, there are fish that can live in these tide pools. Obviously, they have to be small-bodied fishes, and many of them are juveniles of species that, when they grow larger, will leave the tide pool areas and live on the coral reef. Other species, like this blenny, will spend its entire adult life inside the tide pool. Towards the end of the low tide, a lot of the water in the tide pools has evaporated, and a lot of the available habitat for the fishes has dried up. This causes many migrations within the tide pools into the last remaining available habitat, and space is really at a premium at this point. The fish all get concentrated in the last remaining tide pools, and this is where they have to stay until the incoming tide replenishes the water supply. Unfortunately for us, the incoming tide means it's time to leave the area before we get pummeled by the waves too.
So you saw how, fairly violent those waves coming in were. Okay, so you can see here, everybody's crowded into a little spot right here. We can see our sea anemone here in the front. We have our sea stars here, and these are all barnacles up on these rocks here. Those rocks are like full of the barnacles, so we're gonna kind of key in on those guys for a second. We've seen this picture before. These are barnacles at low tide. So they've completely closed themselves up to keep from drying out, right? So they're not allowing any of their water to escape. And remember, they have sharp edges. They've made this shell-like structure right here, and this is the creature with a shell that closes and the creature's inside. So I have this interesting little, no sound on this one, this little video here. It's just gonna show them with their little tentacles out. So when they're under the water, you can see they're opening up that little shell thing, and they're sending their tentacles out, and they're eating, right? But at low tide, of course, they just completely close that up. So you see that little feather kind of structure coming out there for feeding. Yeah. If you've ever seen a really nice saltwater tank, they might actually have living barnacles in there. And you can see them putting their little feathered tentacles out there. Pretty cool. All right, so this guy's called a gooseneck barnacle. And in the past, I have been able to get these for dissection. They end up being about this big, so I'm going to say about 5 inches long or so. Okay? And they have this interesting called the peduncle down here. And then the top, they have this very odd kind of arrangement of shell-like structures that close over the feeding structure. They look like this. All right, so you can see the peduncle there. It looks like it's attached itself to something, so maybe sessile at this point. There's that shell structure, and look at that little feeding part that comes out right there. It's actually very pretty, but like I said, they're only about this big. I think the ones I've had in the past were about maybe 3 inches. So they're not a great dissection, but we've had them before. Here you can see their feathered part coming out of their mouth parts. Look at this arrangement of the shells covering their mouth parts, though. They kind of close in like a little puzzle. Oh, these are some of their egg casings. So along some of the beaches during the time, you can see the little shell part right here, and then this is during the reproduction time. If you go to a restaurant up north, apparently they serve them. I don't know, y'all. What do you think? I mean, I'm assuming they're cooked. Maybe with some yummy garlic butter on them. That makes everything better, right? Snails. We can eat anything that's got garlic butter on it. So, but I don't know that we have them down here. I think they're northern. I think they're in cooler waters, rocky shores. But their internal anatomy looks something like this, which is really very similar to what a sea anemone looks like. In other words, it's a little sac. And then the top part that opens up, and instead of tentacles like the sea anemone, they have that little shell structure right there, and these little feeding parts that come up here. So we call them goose barnacles, and you can see the peduncle down here would be the digestive areas coming down, and the reproductive areas right there. Okay, what about those waves and the violence of the waves? The waves will cause there to be a change. Not sure why I'm talking about this now. A change in the way beaches look. So you've noticed not all beaches look the same, and it has to do with the angle at which the waves are coming in. Okay, so the violent crashing waves affect the organisms. We know that because they travel faster in deep water. When they get to the shallow, they start to break. So remember, the water's just moving up and down, and it hits that and it bumps it up too quickly. The waves tend to approach the shore at an angle. With the bottom wave slowing down, it causes it to bend and break. And that's why we end up with structures that look a lot like this. Especially, see, in the rocky, you have all this rocky, and we end up here, and there might be a protected zone that doesn't get a lot of side wave crashing. Therefore, it has maybe some opportunity to deposit a little beach area, some little sandy area. And this is what Hawaii's like. So you find all these rocky beaches, and then you'll find, whoa, you know, this beautiful like paradise, little place. Some of them have black sand, which are beautiful. Some of them have red sand. And so you'll see that. It's different at our beach. We have a sandy beach in Texas. All right. Here's going to show again the water coming in at these angles, and it causes, look here, we're going to have on the headlands right here, very violent wave action, very rocky shore. But down here, it's a little more quiet, and we can have some opportunity for dropping of sediments like sand, mud, things like this. In order for sand to be there, it's got to be calmer than a rocky shore. So that means the Texas coast, even with, y'all have seen the Texas, we've all been, everybody's been to the Texas coast. There's never a time, have you ever seen a time when the waves were threatening? Not really, right? They come in, they're kind of just soothing, right? They come in, you can hear them break a little bit. But no, I don't know that anybody wants to surf on the Texas coast. California, however, big waves come in, you can surf out there. They do have sandy beaches there, but they have a lot of rocky beaches as well. All right, surviving the waves. Here are some mussels. We've actually talked about mussels before, and they have this strategy for survival where they send out this stuff called byssal threads, and it actually is a very strong rope that'll hold on to something, and they can attach to something, and it's very strong. In fact, trying to get them off, sometimes you have to use a heavy-duty knife tool type of a thing to get them off whatever they're stuck on. It looks to me like they're on top of a bunch of barnacles here. Look like small barnacles. Okay, what's happening here? We have a crab inside a little cave. It looks like it's found a little spot for protection there. I don't know if it's collecting those little shells, maybe for snacks later on, its pantry, something like that. All right, so are we in the middle one now?
Yes.
Noticeable bands of growth can be seen on the rocks at low tide. This is called vertical zonation. Certain species will not be able to survive too low due to biotic conditions like predation, or too high due to abiotic factors like desiccation. They find their niche along the way somewhere. Tide pools. Here we have some seaweed, right, that's going to survive low as long as we get water back there pretty quick. And once again, depending on where you are, sometimes the tide is high, sometimes the difference between low and high is big, sometimes it's not as big. All right, the Mediterranean Sea, for instance, I think the total tide difference is 2 or 3 inches between low and high tide. Whereas on some rocky coasts, it can be, I think the Bay of Fundy has something like 30 feet between low and high tide. That's huge. I think Texas is probably about 10 or 12 feet between low and high. Y'all noticed it all? You can see when it comes up to the beach, where like you can come down and say, oh, here's where it was, and now it's down there. So usually about 20 feet or so. All right, we have everything from this slide. Are we still writing?
I don't think.
Got lots of people writing there. Squeezing things in.
What would you want us to write if
I don't know. What are y'all writing?
we have middle intertidal characteristics, lower intertidal characteristics, ecological succession,
Oh,
and then
here we go.
a big blank for
Here's upper. Here we go. Rarely submerged, just stamp. More terrestrial organisms than marine, like sand or land crabs, if you will. Algae, cyanobacteria are primary producers here. That's interesting. They do okay outside of the water. Gastropods, limpets, crustaceans, those are our crabs. Periwinkle snails. Oh, look at that. Their genus name is Littorina. Littorina from littoral zone. Littoral zone, yes.
Can I take a picture? I don't have any room.
You can. You want to put? Let me get the rest of them up here. I am recording this for your sister, so.
Okay, yes,
Yeah.
I'll have to.
Sometimes it's called. Okay, sometimes it's called the Littorina zone. Huh. Okay. Predators, crabs, birds, rodents. Ooh, raccoons. Boo. Oops. Go back. Do we have everything we need here? This is the upper. I know you filled in some stuff already. And whatever you need to know about this zone, you'll find out in your reading, right? Y'all are reading your modules, yeah?
Yes.
Okay.
I'm in 16.
That's how you do well on tests and quizzes and things, by actually reading the material. Okay, but notice here we do have a lot of land creatures coming in. I mentioned birds earlier. I hadn't thought about raccoons. I've never seen a raccoon on the beach. I've seen rats. Okay, here's the upper zone. Look how rocky that is. Boy, howdy, that is a rocky beach. I couldn't lay my towel out there anywhere. All right, middle. Here we go. Abundant species.
It's really hard.
High tide line to low tide line. Water is regularly covering this area due to tides. Okay, yeah, up and down. Plenty of water, nutrients, plankton, algae, oxygen. So we have barnacles, chitons, limpets. Those are those creatures that can dry them, hold their water inside of them for a little while. Predators would be starfish. Crustaceans would be crabs. Boring whelks. Not as in dull, but boring as in they drill a hole right through you and eat you. Wave action can be intense here, so they have to be able to withstand that. I feel like I should make these words bigger. Can y'all read them okay?
Yes.
You can see them over here in the corner, Mallory? Zoe, y'all can see those? Is it blurry to you? Is it? Because it's blurry to me. I just thought it's because I have old eyes. Better? That's a little better, yeah?
Yes.
Did that help?
I didn't even notice it was blurry until now.
Okay, there you go. That's your young eyes, just, you know.
Cannot even tell you what.
Okay, here we go. This is some of our middle guys, right? They're underwater, they're not underwater. I think those are barnacles. It could be mussels. Look at all the algae down here. They're loving the sun. Here we can see some starfish. Oh, that's interesting. We have that cool looking one right there. Looks fake. What else do we see? I see some barnacles over here, some shells over here. Lower zone. Okay, the lower intertidal zone is underwater most of the time. There can be times when the tide gets low enough, you know, like in neap tides or something like that, that it would be out of the water for some time. It contains the greatest diversity of organisms. All right, so we see sea anemone. I guess that's a crab down there. Some starfish. We see some kelp or whatever that is. Is that kelp? Oh, it doesn't label it. Okay. Big fish, larger fish down here. Remember those larger fish don't stick around for low tide. They can't.
The larger fish don't?
They can't, yeah, because they have to. Even in a tide pool, the tide pool may not be big enough for them. All right, did that give you something to write down in lower intertidal zone? Okay. And then are we moving on to ecological succession? That's what I've got coming up now. So ecological succession is a gradual takeover of a new organism in an area. All right, it's more difficult to describe this in a marine environment because they don't change as much as land environment does. But around here, we know this, where we have a big, giant, beautiful pine forest, and then it gets burned down by a giant fire. How long ago was that? 10? 10 years? 12 years? Were y'all all here when that happened? Yeah, some people weren't here and they don't know. The whole Bastrop burned down.
I think it was 11 years ago.
11 years ago?
As of 2011. So yeah,
2011, okay.
it'll be
22, yeah,
it'll
okay.
be 11 years this fall.
This, it's actually happened in September, yeah.
Yeah.
I remember it happened on September 4th and 5th, my son's birthday.
We moved in the day before the fire started. We moved from Michigan to Texas.
You're kidding me.
Yep. Well, actually, our moving van showed up the day before the fire started. The moving van showed up, unloaded all of our boxes. We're in the historical district downtown.
Okay,
We didn't
so it
know
didn't-
anyone, so all we saw was smoke and like, what
You're
is
like,
going
what's
on?
happening here? So y'all didn't lose anything.
We
You
didn't lose
anything.
anything, but
Because y'all are surrounded by the woods.
I had lots of friends who lost everything.
Yeah.
But they're okay. They didn't lose their lives.
Yeah, the Paulos.
Yeah.
Lost a lot.
Yeah. So Audrey's grandparents. Yeah. We had some friends who lost everything. Yeah. Okay, but you see what happened? If we go drive over to that area now, what does it look like? Beautiful, right? We even have more pine trees growing. There were years, of course, we drive out 71 and they're just black sticks standing there, you know. But now you go by and people would say, oh, there was a fire here? They don't even know it. So, and it was a big deal around here.
So what's up then with, if you go down, I cannot remember if it's 71. I think it's a little ways down 71, but it's also some other areas where it's just like barren trees. What is that?
That
Is that
could
as
have
a
been-
result of the fire?
It could be.
Okay.
Yeah, it depends on where you are, because there was a second fire that came a couple years later.
Okay.
That was over by what was
was
called
at
Wilderness
school.
Ridge area.
I don't know.
There was
That's
a
not
camp
very
for
well.
boys called Wilderness Ridge. Y'all know that one? It burned down twice.
Oh.
Twice. You're thinking maybe God's done with that. Okay. All right. So here was our gooseneck barnacle lab that we're not doing. All right, but that's what. Remember, they were only about this big, so it wasn't very impressive. So y'all, I had to just make up a lab because our sea anemones did not make it, and we didn't have any barnacles. So we have something else.